Okay, so we've been talking about solving systems of equations for a little bit, and today we want to get into why. Why are we talking about solving these systems and with these methods of graphing, substitution, and elimination? And there are times where something comes up in our lives where setting up a system of equations can help answer some questions a little bit easier than not using algebra. So we're going to talk about that today in some instances where that could help. We've been talking about which method to choose to solve a system. We want to continue talking about that. We'll mention that just for a couple of seconds here in the notes before we get to our story problems and those real-world situations I was telling you about. So get going here. Again, just a quick recap. When do we want to use the graphing method? When do we want to use the substitution method? When do we want to use the elimination method when we solve a system? Graphing method's is not used very often. It's not very common just because it's difficult to set up. In terms of you would need some graph paper to make the graph, the graphing the two lines as accurate as possible. There are times when just being able to have a visual display of an equation is helpful. Just so you can kind of get a sense of what each equation is doing and give you an overall picture of a particular situation. And if you don't really need an exact solution, then the graphing method could work pretty well. But otherwise, if you're looking for an exact solution, an exact point, then the graphing method becomes kind of a problem. We talked about it already, substitution. We want to use the substitution method when we have our two equations for our system, and one of the variables is easy to solve for, right? It doesn't have a coefficient, so it's sort of naked, I guess, or a variable is already solved for. Then we can just go ahead and plug into the other equation, then substitution becomes easier. Elimination is my favorite. I like to use it a lot. I think it's a little less work involved, a little bit more thought, a little bit less work. And that's when we want to use that is when the variables are kind of all lined up, everybody's lined up, and we can make opposites pretty easily so that when we add the equations together, one of the variables adds out to 0 and gets eliminated, right? So we talked about all that stuff. Here are three systems. Which method would you use if I gave you these particular systems? And some of you guys like to force your way into a particular method of solving, whether it's substitution or elimination. But I'm telling you, if you can be a little bit flexible in whichever method that you use, if you can use both, then life becomes a bit easier, right? In this first one, which method would you use, right? Hopefully you're thinking substitution, because y is already by itself, right? So we could just go ahead and plug 2x minus 5 in for this y right here and go to work and solve for x. Okay? The next one. Some of you guys might be thinking about substitution, but what I would actually use is elimination. Right? This x's are already opposites, so if you go ahead and add the two equations together, those x's will add out to 0, eliminating one of those variables. I do recognize the fact that all you'd have to do here is add 7x to both sides, and you would have y by itself, and then you could do substitution. That might be just as easy this time, but since I can get to elimination pretty easily, and I like elimination, I would have done elimination on this system. And the last one, if you look, I think is set up for you to think about doing the graphing method. I would not, because I don't like the graphing method. I think it's a little bit tougher to set up, and it's not as accurate. I actually would probably use substitution. I would take the 1/2 x plus 4 and plug it in for that y. So I would say substitution, graphing method if you just want to see the equations and kind of get an overall picture of a situation. All right? Anyway, I know we've talked about all that before. So let's dive right into our story problems, right? Why are we solving these systems? I've said it before, I'll say it again. I would love to be able to give you a step-by-step process on how to solve a story problem. The problem is they're all different. And even if setting up one makes a ton of sense to you, the next one might not. And it's just a matter of seeing some of these and giving them a shot, right? So writing is trying. You've got to write out your equations, and then if you're wrong, talk about why you're wrong, and change it and learn from it, okay? So we'll dive into some examples here that I think will help at least develop a thought process for you, right? So suppose you bought supplies for a party, 3 rolls of streamers and 15 party hats. The first trip that you went cost you $30. Then you went back and bought 2 more rolls of streamers and 4 party hats for $11. So how much did each roll of streamers and each party hat cost? Well, yes, I understand that when you go shopping for these things, the store will tell you how much each of these cost. But again, we're trying to use something easier to set up some more difficult stuff later, right? So we get into our story problem methodology here. How much did each roll of streamers and each party hat cost? That tells you how many variables we need and how to define those, right? We need 2 because we don't know how much the streamers cost and we don't know how much the party hat costs. So that's how we're going to define these 2 variables, right? So X is the cost of the streamers, and Y is the cost of the party hats. Not total cost, but each, I guess. Each of the streamers and each of the party hats. Okay? So, if we look, the 2 equations, and since we have 2 variables, we're going to need 2 equations. And the 2 equations come from the 2 times you went to the store, right? So the first time you went, you got 3 streamers and 15 party hats, and that cost you $30, right? That's your total cost. Well, in order to come up with that total, you'd want to take the 3 streamers, the fact that you bought 3, and multiply it by the cost of each one. Well, that's what we let X be. So 3 times X is 3X. And then we want to take the cost of the party hats, which is Y, and multiply it by how many that you bought, which was 15. Right? So this is your first equation. And if you're standing in line at the store, that's how you'd come up with your cost, right? Take the cost of each one and multiply by the number that you got. So your second equation comes from when you go back the second time, right? 2 streamers, so 2X, and 4 party hats, so 4Y, end up costing $11. So there's your 2 equations that you need for your system. And now you want to go through and solve it, right? For me, elimination is going to be a bit easier. I'm going to eliminate the x's by multiplying the first equation by -2 and the second equation by 3. Multiply by -2 in the first equation because I need the x's to be opposite signs. So you're going to -6x minus 30y equals -60, and then 6x plus 12y equals 33. Hopefully we can solve a system at this point. We've been working on that for quite some time. Okay. And then divide both sides by -18, and we get 3 over 2 when we reduce. But now we got to think about what y stands for. And y stands for the cost. It's a cost. 3/2 does not give you a cost. So go ahead and divide it out, and you'll get 1.5, or since it's a cost, it's money, so $1.50. So the party hats cost you $1.50 a piece. To find out how much the streamers cost, we've got to plug that $1.50 in, and we can do that right there. So 2x plus 4 times $1.50 equaled $11. And so 2x plus, let's see, 4 times $1.50 gets you $6. Subtract 6, divide by 2. And now again, you want to go ahead and divide it out and get a decimal because we're talking about money here. So you get 2.5 or $2.50. And so a nice sentence answer, which I'll write the first time, but I won't write every time just for time purposes. But so each roll of streamers costs $2.50, and each party hat cost $1.50. Okay? All right. Good. So, like I said, the next story problem is going to be a little bit different. So, take a second and try to come up with your two variables. The equation will tell you that. How long does it take to make each small and each large centerpiece? Define your variables and then give a shot at setting up the equation. Again, writing is trying. So you have to write something down and then check it to see if it's right. So go ahead and stop the video, give it a shot, and then I'll talk you through how to get it. Okay? So, we do need two variables because we don't know how long to make a small centerpiece, and we don't know how long it takes to make a large. So the time it takes to make a small one is X, then Y is the time it takes to make a large one. Right? So again, your two equations, and you need two because you have two variables, comes from each sentence basically. The first sentence says that 3 centerpieces and three smalls and 3 larges took you 3 hours and 15 minutes. So to find out your total time, the 3 hours and 15 minutes, I got to take the time it takes to make one small one, which is X, and multiply it by 3 since we made 3. And same thing for the large. So 3X plus 3Y. And then it says 3 hours and 15 minutes. Now, it's hard to put 3 hours and 15 minutes into this equation just like that, 3 hours and 15 minutes. So we could make it a decimal, I suppose, in terms of the number of hours. But I think it's easier to make this to convert this into minutes. 3 times 60 is 180, plus 15 minutes is 195 minutes. So this has to equal 195 minutes. And your next equation comes from this right here. Right? And it's going to set up the same way. So 4 smalls and 7 larges has to equal 6 hours and 20 minutes. So 6 times 60 is 3,600 plus the 20 minutes, so 3,620. And there are your two equations. Okay? Elimination again, multiply by -4 and +3. And the first equation turns into that. Second equation turns into that. Add those, you get 0. This becomes 9y equals 10,080. Divide by 9. Alright, so the answer I'm getting is very wrong. It doesn't make any sense. So I look back up here, and apparently I said 6 times 60 was 3,600. It should have been 360. It's my fault. See, even teachers make mistakes. So now when you add 20 minutes to that, you should get 380. So there should be 380 instead of 3,620. All right, let's back up. 380 times 3. This should be 1140. And 1140 minus 780 should give you 360. Divide by 9, and so 40. So it's going to take them 40 minutes to make a large centerpiece. And then to find out how long it's going to take to make a small one, we plug that back in. So it's going to take 25 minutes to make a small one. Okay? Oops, sorry about that. There you go. Okay? All right. Stop the video. Try to come up with this one. Even a little bit more different. than the last two. Okay? But then start it back up and check to see if you're doing it right. Okay, so question. What are the dimensions of the rectangle? So you got a rectangle. What we mean by dimensions is a rectangle has a length and a width, right? So we can actually define two variables that way. L is the length, W is the width. Now if you used X and Y, that's fine. Either way, right? You can even have them switched, where the length is Y and the width is X, right? But anyway, your two equations come from the two sentences, right? The first one says that the length is 3 times the width. And you can do this like going from a verbal phrase to an expression or an equation, right? The length, which we've defined as L, or X, is means equals 3 times the width. So take the width and multiply it by 3. And that's your first equation. The second equation comes from the fact that they give us the perimeter. The perimeter is 44 centimeters. That means that when we find the perimeter, we get 44. How do you find the perimeter of a rectangle? Well, you add up all the sides, right? There's 2 L's and there's 2 W's. So you could go 2 times L plus 2 times W and set that equal to 44. And then go solve that. This sets up well for substitution. So I'm not going to force my way into elimination. I'm going to go ahead and do substitution because it's easier. Right? And so we divide 44 by 8. And we get 5.5. And I want to do a decimal because this is a length, right? This is 5.5 centimeters, which makes more sense than telling somebody it's 11 over 2 centimeters long, right? Or wide. And then to find the length, I'm going to plug the 5.5 up into the first equation because it's easier. And you get 16.5. So the length is going to be 16.5 centimeters, and the width is 5.5 centimeters. Okay? All right. Try 7. Stop the video, start it back up, and see if you're right. All right. So now X and Y stand for two numbers. One's smaller and one's larger. So the sum, so if I add those two together, it needs to be 27. That's easy enough. Second equation comes from the second sentence. And again, you're using a verbal phrase to write an equation. The larger number, which is Y, means equals 3 more than the smaller number. So take the smaller number and add 3 to it. So those are your two equations, right? Sets up for substitution. So X ends up being 12, so that means the smaller number is 12. And then we need to go 3 more than that to get the larger, which is 15. Okay? All right. Next one, coin problem. We've actually seen one of these before, so stop the video, try to set it up, and I'll walk you through it. All right. So X and Y, two variables because we don't know how many nickels she has, we don't know how many dimes she has. And make sure that you're very specific when you define your variables. X is equal to the number of nickels. Y is equal to the number of dimes. So that when you solve for your variables, you know exactly what they stand for, right? So now, if we take the number of coins that she has of each and add them together, we should get 28 because she has 28 coins, right? Well, now I want to take those amounts, the number of nickels, the number of dimes, and the number of coins together, and turn those into how much money that gives you, right? Apparently 28 coins gives you $2.25, which I'm going to make 225. I'm going to put that in terms of the number of pennies so I can get rid of decimals, right? Well, if you have X nickels in your hand, then to find out how much money that is, you got to take the number of nickels times 5, because that's how much nickels are worth. And same thing for the dimes, right? So your two equations become 5x plus 10y equals 225. Again, getting rid of decimals by just writing them in terms of how many pennies that means, okay? And then you go solve. I would multiply the first equation by -5. Some people see this as substitution being just as easy, and I suppose it could be, but less work involved with elimination, less places to make a mistake, more importantly. So you get 17. So Christy has 17 dimes. You can use some common sense or actually plug 17 in for y and get 11. So 11 nickels and 17 dimes. Okay. All right. Last one. Try to set this one up, stop the video, start it back up, and see if you're right. So your two variables, we don't know how many adults and we don't know how many children are attending. So those are your two variables, x and y. Or you can use other variables if you want. Since there were 212 total people, when you add the x and the y, you should get 212. And then like the coins, we want to convert that over to how much money that brought in, right? 212 people brought in $1,128 total dollars. Now, the adults were $6 each. So to find out how much money they brought in, take the number of adults that there were and multiply it by 6. Same thing for the kids. $4 each. And there you go, right? I would use elimination. I would eliminate y. Okay, and so then you can solve for x. So there were apparently 140 adults there. If there were 140 adults, then just subtract that from 212, and you'd find that there were 72 kids. Okay? So, I mean, like I said, lots of different story problems in this set of notes. Hopefully each of these can help you a little bit on your homework, which is sitting out in Canvas. So go ahead and knock that out. Remember, the only way to get this to get better at story problems is to just do it. Writing is trying, and then find out why you're not getting the equations correct. Okay? All right, knock out your homework.